Section 1.5, Solving Inequalities. Now, when you're solving an inequality, this should be something that's relatively familiar to you. However, if it's not yet familiar to you, we're going to teach it as if you haven't seen it before. I've got a little song to help you remember the one special thing that happens when solving an inequality that doesn't happen when you are solving an equation, or that you don't have to at least deal with when you're solving an equation. And that's when you multiply or divide both sides by a negative, you have to flip that inequality sign. So the little song goes like this. If you multiply both sides by a negative, switch the sign. If you multiply both sides by negative, switch the sign. Oh, I sing a silly song, so you won't get the problem wrong. If you multiply both sides by a negative, switch the sign. You can also say the same for division. If you divide both sides by a negative, switch the sign. If you divide both sides by a negative, switch the sign. Oh, I sing a silly song, so you won't get the problem wrong. If you divide both sides by a negative, switch the sign. So, when you are working through these problems, pay careful attention to when you have to actually use division or multiplication, and the number that you are dividing or multiplying by is a negative number, because that inequality has to flip directions. Also, when you get to graphing, when you are graphing these inequalities, since there's only one variable, we're going to graph them on a number line, and we will use an open dot when it does not have the equal to sign attached to it, and a closed dot when it does have an equal to sign attached to it. To help us when we are graphing, we are going to write all of our inequalities in what I call Venn form. The variable first, then the inequality, and then the number. So example would be x is greater than 2. X is greater than 2 has the variable first, then the inequality, and then the number. If you were solving and you ended up with something that looks like this, you can flip that around by putting the variable first, and then the inequality will open towards the variable because it was opening towards the variable in the original. So x is greater than 2 may also appear like this when you're solving. So let's take a look at a couple of examples. Number 1 asks us to graph the solution set on the number line. So our first step will be to subtract our 4y from both sides. You could also choose to subtract the 5y from both sides. Just keep in mind that would give us a negative. Then we need to subtract 2 from both sides. And we can see that this has not put ourselves in a situation where we have the variable first, then the inequality, then the number. So we're going to flip that around so that the variable is first, and then our number is last. And take a look at the inequality. It's opening towards the variable, so it needs to continue to open towards the variable when we rewrite it. For our graph, you need a number line. You also will need to put at least 3 numbers on your number lines. -5 was my solution, so -5 will go in the middle. And to the left of that would be -6, and to the right would be -4. I notice that there is not an equal to sign on there, so I'm going to use an open dot when I'm graphing this. Right directly on the number line, right at -5. The reason why we write this in variable inequality number or Venn form is because this kind of acts like a little arrow. It points in the direction that I should shade. It's pointing to the right, so I'm going to shade to the right. Make sure that your line is dark enough or in a different color that I know what direction you shaded in. We can check that we shaded the right direction by taking a number and plugging it in to see if it works. Negative 4 is greater than negative 5, so I know I've shaded in the right direction. Take a look at B. For B, we need to divide both sides by negative 0.3. As my silly song told you, when you divide both sides by a negative, you have to switch that inequality symbol. So 12 divided by negative 0.3 is negative 40. And it's no longer greater than, it's now less than or equal to. So we're going to rewrite this with the inequality in the middle and the variable on the left, the number on the right. The inequality was opening towards the P, so it needs to continue to be open towards the P. When we graph this, negative 40 will go in the middle, and then I have negative 41 and negative 39. If you would like to put more numbers, you're more than welcome. The minimum requirement is 3 numbers. This time I have an equal to symbol, so I'm going to use a closed dot. And it's pointing to the right, so I will shade to the right. We can verify that we shaded this correctly by taking our number to the right and seeing if it works in the inequality. Negative 39 is greater than negative 40, so I know I shaded it right. For C, we need to get rid of that 2 in the denominator. Remember we said whenever there's a variable I'm trying to get by itself and it's part of a fraction, we need to multiply by that denominator to get rid of it. So we will multiply both sides by 2, giving us negative 2x is greater than x minus 7. Now we have to subtract x from both sides. And negative 3x is greater than negative 7. And divide by negative 3. When you divide both sides by negative, you have to switch that sign. So it now becomes x is less than 7/3. Now in this case, when I draw my number line, I'm not going to put 7/3 on the number line because that would mean that I would have to put other fractions on either side. Instead, I can use my calculator to figure out that 7/3 is between 2 and 3. When you divide on your calculator, you have 7 divided by 3. It gives you 2 point something. 2.3 in this particular case. So we're going to include 2 on our number line, 3 on our number line, and at least one other number. An open dot would be appropriate because it doesn't have an equal to. Just approximate where that is on the graph. This time it appears that the arrow is pointing to the right. So I'm going to shade, it appears that the arrow is pointing to the left. So I'm going to shade to the left. And I can double check that I did that correctly by plugging it back in. 1 is shaded on here, so 1 should work here. 1 is smaller than 7/3, and that's true. For D, I can see I forgot a parenthesis here. We'll fix that. My first step would be to distribute that negative 4. Negative 4 times 6n is negative 24n. Negative 4 times 70 gives me negative 280. Greater than or equal to 122. Then we're going to combine like terms. I have 6 and negative 280. So those can combine together. Negative 24n. And 6 and negative 280 combine together to be negative 274. Then we're going to add that 274 to both sides. I'm left with negative 24n is greater than or equal to 396. Divide both sides by negative 24. So n is now less than or equal to because we divided both sides by a negative. And if you did it in your calculator, you would see negative 16.5. I'm going to give you permission because it's a terminating decimal and we're graphing. You may want to write that as a decimal instead of a fraction. Here's our number line. Negative 16.5 lies between negative 16 and negative 17. And then we need one other number on that number line. I'm going to use a closed dot and approximate the middle because it's 0.5. And it's pointing to the left, so I'll shade to the left. Take a look at the next page. Javier has at most $15 to spend today. He buys a bag of pretzels and a bottle of juice for $1.59. And his gas at this store is $2.89 per gallon. How many gallons of gasoline to the nearest tenth of a gallon can Javier buy for his car? We're going to set up the equation. We know right off the bat that Javier spends $1.59. And then he buys some gas. We're going to add to that the amount of money that 1 gallon costs times the number of gallons that Javier is going to buy. And the most amount of money that Javier has to spend is $15. So since this is the bigger number because that's the most he can spend, it's going to open towards that number and it's going to have an equal to because he's allowed to spend exactly $15. So to solve this problem, we're going to subtract 1.59 from both sides. $15 minus 1.59 gives me 13.41. Then we're going to divide both sides by 2.89. So x is less than or equal to, and it's said to the nearest tenth, so that would be 4.6 gallons. The most amount of gallons that he can purchase is 4.6. Number 3. We have to write an inequality for each of these problems and then turn around and solve it. So it says the difference of, and that should say 5 times the number. The difference of 5 times the number and 3 divided by negative 3 is less than negative 4. We're going to take that phrase by phrase. It says the difference, that means subtraction, of 5 times the number and 3. So 5 times the number and 3, and we said that difference was subtraction. And it says that divided by negative 3 is less than negative 4. Again, to get a variable alone that's a part of a fraction, we have to multiply by the denominator, which happens to be negative. So we have to switch our inequality sign. Add 3 to both sides. And we get that 5x is greater than 15. Then divide by 5. And x is greater than 3. Number 4. 5 less than the product of 6 and a number is no more than twice that same number. I want to point out to you that in this case, less than will represent subtraction, but when we saw less than above, it represented an inequality. That's because of the word is. Anytime you have is less than or are less than, that verb with less than, it indicates that that's an inequality. If we just have a number is less than or a variable less than, then that's indicating a subtraction. And remember that this is one of those turnaround words. So that means that 5 will actually be after the subtraction sign. So 5 less than the product of 6 and a number. So that means 6 times a number. And there's 5 in reverse order of what they appeared in words. And it says is no more than twice that same number. So twice that same number. And is no more than means is not bigger than. That means that the 2x has to be bigger than or equal to. So we are going to, in this case, subtract 6x from both sides, leaving me with negative 5 is less than or equal to negative 4x. Then we're going to divide by negative 4. So I get 5 over 4, and we divided by a negative, so it's no longer a less than sign. It's now a greater than or equal to sign. And just for ease, we will rewrite this in variable inequality number form. So it was opening towards the 5/4. It will continue to open towards the 5/4.